Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle. And it's called The Special Theory of Relativity by Tobias Brixner. Excuse me. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Each cage marks a spaceship that is initially at rest in the solver's reference frame. That is the grid. Oh, interesting. So this is actually going into the special theory of relativity. Very cool. Digits may repeat within a spaceship if allowed by other rules. Okay, so that's not normal killer cage Sudoku. I guess this is just normal cage Sudoku. But digits are allowed to repeat if allowed by other rules. Each spaceship then accelerates to a high velocity and moves in an orthogonal direction without changing its orientation. So, okay, each spaceship moves and it moves in an orthogonal direction, which means it would have to go either horizontally or vertically, so that this spaceship could go somewhere down here or something like that, right? So it could move that way, or it could actually move somewhere along here, right? Could be here, or it could be this one, whichever one, right? It just cannot move diagonally, it seems. So this is not valid because it's moving in two directions at once, which I guess is not allowed. And we have to find the new position that is fully, okay, so the new position must be fully inside the grid. So it cannot go like this because it doesn't fulfill all the cells in the spaceship, right? Another rule is spaceship position marks must not overlap. So this is actually not valid because it would overlap with this. We can remove the red. Oh, actually, that's very interesting. That's actually extremely interesting. That tells us a lot, actually. So spaceship positions must not overlap. Okay, as a consequence of the special theory of relativity, each moving spaceship is contracted along its direction of motion. Wait, what? Okay, so it doesn't maintain its same shape. So that's okay. It shrinks, I guess. Is contracted along its direction of motion. That is, its shape is scaled down in the solver's reference frame. I guess because of the special theory of relativity. The length of the spaceship at rest divided by the observed length of the spaceship in motion is called Lorentz factor. The size is unchanged perpendicular to the direction of motion. So it shrinks. Okay. Okay. This is wow. Hmm. Okay, so then I guess if it goes in this direction, it has to shrink, right? So this could be something like this is valid if it goes this way. If it goes this way, it shrinks in another direction, right? So then all of these would shrink. I don't know. What's confusing to me is that, so it makes sense in this sense, right? But does this become zero? I don't think that's possible, right? So if it goes this way, the size of the width, the thing that's perpendicular to the direction of motion. So it's going this direction of motion, right? Which means it shrinks in that direction. So I think this would have to go down that way, and this would have to go down at least one here. It could be something like this, or this potentially. Um, but what happens here if you have one, right? That's what's confusing me. If this is one, and it goes this way, does it become 0? Right, because it's going this direction. Or does it become 0 then? Because it would have to shrink, but it can't shrink this way. Maybe that's part of the how you solve it. Anyways, let's continue. The length of the spaceship at rest divided by the observed length of the spaceship in motion is called Lorentz factor. So that would be this divided by this. Or this divided by that. So that's the Lorentz factor, whatever this division is, right? The size is yeah, that's what the thing. I said the size is unchanged perpendicular to the direction of motion. The energy of a spaceship is given by the sum of its digits. Sorry. The energy of a spaceship is given by the sum. Yeah, I just said that. The energy of a spaceship in motion is equal to its energy at rest, which is a sum of that, multiplied with the Lorentz factor. Okay, so let's just take one that's easier. Let's say we have this, right? And then it shrinks to, I don't know. Let's say it shrinks to 1. Then the Lorentz factor here, the length of the spaceship at rest, which is 4, divided by the observed length, which is 1. So the Lorentz factor is 4 here. The energy of this spaceship is whatever the sum is, and the energy of this spaceship is equal to its energy at rest multiplied with the Lorentz factor. Wait, so this has to be greater? Yeah, it has to be greater than the energy of the spaceship at rest. Right? Because so the length always contracts. So the length of the spaceship at rest divided by the observed length of the spaceship in motion, it will always contract. So therefore the length of the spaceship in motion is always smaller than the length of the spaceship at rest. Huh. So it's always greater. So right. So the spaceship in motion that's moving, essentially, will always shrink, right? It contracts because of the visual, of the special relativity. Things that go really, really fast are essentially shrink in. Um, I don't even know if that's necessarily the case. Is that I'm assuming it's correct. That's the correct way. It contracts, which I guess it's kind of counterintuitive, right? Because if it's going really well, I don't know, maybe if it's going really fast, it basically shrinks essentially. So the Lorentz factor is the length of the spaceship at rest, which is a larger number, divided by the observed length of the spaceship in motion, which will be smaller than it. So that's the Lorentz factor. So the Lorentz factor is always greater than 1. The size is unchanged. Okay, yeah. And the energy of the spaceship in motion. So the energy of a spaceship is given by the sum of its digits. So that's whatever just it is. The energy of the spaceship in motion must equal its energy at rest multiplied with the Lorentz factor. So the smaller spaceship must always be more than the original one was. The original spaceship sum, because the Lorentz factor is always greater than 1, right? So since it's always greater than 1, it's always the sum has to be always greater than the original sum. That's actually very interesting. And then finally, we have the final rule, which is cells connected by an X sum to 10. So for example, if this were, say, a 3, this would have to be a 7 to add up to 10. Pretty crazy rule set, actually, I must say. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so from what we learned then, this then has to essentially become a smaller version of itself, and the factor has to be 2. Right? Because there's no other, like, I'm pretty sure it has to be, obviously, the Lorentz factor has to be a single number, right? It can't be multiple numbers here, right? Because the spaceship can't shrink at multiple ways. So if this shrank in divided by 2, but this shrank like essentially divided by 4, that's not valid. I'm pretty sure, right? So and it has to go this way, right? Because this can't shrink the same amount that this would shrink, right? You can't have half a cell be part of that. So it has to be 1 and this has to be a multiple of 2, essentially. So whatever 3 digits you have has to be a multiple of 2. Has to be essentially the energy of this must sum up to what this is times 2. Well, the most this could be is 26, right? Because it could be 9, 9 with 8. The least this could be is 13. Well, there you go. So then this would have to be, because this adds up to 10, and this adds up to 3 at least, right? This is 1, 2, 3, 4 at minimum. This is 1 and 2 at minimum. So this would be 1, 2, 3, 4 plus 1, 2. If we tried to have it anywhere here, it wouldn't work. So this must be the cage, which means this adds up to 9 and 9 and 8. This must be a 1, 2 pair. This is 3 and 4, and this has to be 1 and 2. So 9 has to be, this is now 5 through 9. Obviously, neither of these could be 9. This can't be 8. This is 5, 6, 7. So this is the shrunken spaceship. One of these is 9. What about this? Well, I'm not really sure. Because it's kind of confused. So 1 and 2 have to be here. We don't know which one. So again, this is 13, this is 26, and this is multiplied by 2. It cannot go down to 1, because then that would be 9, and that would be 15. Can it go down to 2? That would be 8 and 9. This would be at least 15. But this would be multiplied by 5 divided by 2. So that's not possible. What about 3? If you have 3, you would have 5 over 3. This is at minimum 15. So 5 over 3, minimum 15, which means 15 divided by 3 is 5. So that would be 25 for 3 digits. So that's not allowed. So this has to be essentially the spaceship this way. And again, I don't think it can go this way. It can't go in this direction because the problem is it can't shrink to 0, right? So it has to be 4 this way, which means this spaceship has a Lorentz factor of 5 divided by 4. So all of them add up to 45. So this is equal to 5/4 of this energy, which means the total is 9/4 energy, right? Because if you add them together, this is 1, this is 5/4 of this energy, so this must be 9/4 total energy. Wait, but that doesn't work. Um, well, no, yeah. Divided by 4, 45 divided by 4. Yeah, that doesn't work. Huh. Right, because this has to be 7, 8, 9 at minimum. But the thing is, if you make it 4, that would be 5/4. And the total of this would be 9/4. But if you take 45 divided by 4, that's you have a remainder left, which doesn't work. But we tried this with 15 here. And this has to be 15 because it's all one line. And the problem is if you have 15 divided by 5/3. Oh, is it divided by? No, it's multiplied by 5/3. 15 multiplied by 5/3 is 25. But the 3 digits you can have at most is 7, 8, and 9, which is 24, which is not allowed. Hmm. How does that work then? And again, if you try to make it 5 to 4, that doesn't work either. Right? Because then this becomes 9/4. Unless I'm really misunderstanding how this works. If you have 45 divided by 9/4. Oh, divided by 9/4. Okay. Right, 9/4 x equals 45. So then you multiply each side by 4/9. Right. That works. Okay. So yeah, that is correct. What I was saying was correct. Right. So this has to be this way. So you multiply by 4/9, right? Or divide by 9/4, which is the same as multiplying by 4/9. So the sum of the 5 digits cell cage is 45 times 4/9, Well, 45 divided by 9 is 5, times 4 is 20. Right? And then this would be 5/4 of that, which would be 25, which works. Okay, yeah, so this adds up to 20, and this must add up to 25. And it cannot contain 1, it cannot contain 2. So this is 25 without a 1 or 2. It has to contain a 9. So this could be 3. 25 would have to be 22. So 3, 5, 8, and 9 works. 3, 6, 7, 9 works. Or it could be 4. 4, 7, 9 works. Oh no, it's 25. 4, 5, 7, 9 works. It cannot be 4, 6, 7, 8 though. If this is 5, this would these three digits would have to add up to 20. But the only possibility would be 5, 6, and 9 that includes a 9. So this can never be 5 then. So this is either 3, 5, 8, and 9, or it's 3, 6, 7, 9, or this is 4, 5, 7, 9. So either way, there has to be a 3 or 4 here. Yeah, those are a lot of possibilities. Okay. This one has to shrink here. This one shrinks to 3 at most. This one can go down to here, or it could go over to here. So this is in a 2-to-1 ratio. Bingo, okay. This is in a 2-to-1 ratio, and it has to shrink. The thing is, this is at least 1 and 3, and this is at least 1 and 3, because if it's 1 and 2, it eliminates all possibilities for that cell and that cell on either side. So this is at minimum 8. Well, if you double it, that's 16. So it has to specifically be doubled then, right? So this is 8, and the minimum value you can have in a 2-cell cage is, sorry, the maximum you can have in 2-cell cage is 17, but that's not 2 times anything. So if you want 2 times something, it has to be 16. So this is the minimum here would be 8, and the maximum in a 2-cell cage is 16. So therefore, it does have to have a 7 or 9. Therefore, this must be 1 or 3, and this must be 1 or 3. That means this can't be 1, so this is a 2, which makes that a 1. This can't be 1 or 3, so this is 2, which makes that a 1. This can't be 3, so this must be a 4, actually. And the only possibility we had was 4, 5, 7, 9, adding up to 25. So the rest of the digits must be 3, 6, and 8. And these can't be 8, so we have a 3, 6, 3, 6 pair in row 1, which eliminates 3, 6, and 8 from the 3, 6 from the rest of the row. So this is 1, 2, 8. And 5, 7, 9 is eliminated from the rest of box 1 because we have a 5, 7, 9 triplet. This can't be 5 or 7, so this must be 6. This can't be 5, 6, or 7 anymore, so this must be 8. We don't know which way this goes. So this is 7 or 9 because it adds up with 1 and 3 to add up to 10. This is at least 10. And if you try to shrink it to 2, that is 17 at most. And that would be a multiplier of 2, so that would mean 20. which is not possible. So it has to shrink to 3 here. Actually, I think that's for all 4s. So this 4 must shrink to 3 here. This 4 must shrink to 3. So one of these. So these actually, well, it just can't overlap. We just don't know where. Okay, this can't be 3 because of the 1, 3 pair in the column. So this must be 4. This must be 3. Which means 1 and 3 are here. The rest of this is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. So actually, at a minimum, this is 1, 2, 3, 5. Well, also, the value of the one that's being here has to be at least what? It's 4/3 times whatever this is, right? And this would be at minimum 1, 2, 4, and 5. So 1, 2, 4, 5 is 12. And if you take 12, you multiply it by 4/3, which is the Lorentz factor for this one. 12 divided by 3 is 4, so it would be 16. Well, that would be 2, 6, and 8, which is not possible. So then what other possibilities are there? So it could be 15 times 4/3, which would be 20, which would be... Oh, it doesn't have to contain a 6 and an 8 necessarily. It could contain just one of them. So I think 15... Okay, so if you... It's either... This adds... If this is 18, it's too big, right? You have 18 divided by 3 is 6 times 4 is 24. But this can never... This has to contain 1 out of 6 or 8. Or 2 out of 6 or 8, but 6 or 8 doesn't seem... 6 and 8, 20... 4 doesn't add up, right? It'd have to be 7, 8, and 9. And none of these are 7, 8, and 9 here. So this can't be 6 here. The remaining digits here are 3, 4, and 6. The remaining digits here are 5 and 7. So, yeah, if we tried 18, that's 18 divided by 3, which is 6, times 4, which would be 24. But you have to have a 7, 8, 9 in a row, and this is never 7, 8, 9 in a row. So 18's out. What if you have 12? It would specifically have to be 1, 2, 3, 4 here then. Sorry, 1, 2, 4, 5, because you cannot have a 1 and a 3 in this cage together. You can only have 1 or 3. So this would be 1, 2, 4, 5. So it'd be 12 divided by 3, which is 4, times 4, which is 16. So it could be 3, 6, 7 here. That would be possible. So then this would be 3, 7, and this would be 6 if it's this one. And it would specifically have to be 3, 6, 7 to add up to 16, because 1, 2, 4, 5 is taken here. This would be a 9. What about 15 then? If it's 15 divided by 3 is 5, times 4 is 20. So if you have 8 and 6, it would have to include an 8. Similarly to the 8 and 6, it would have to add a 2, but the problem is the 2 would have to be here, so that's not allowed. So you can never have 8 and 6 together to add up to 20, because that would be 8, 6, and 8. So it has to be... It cannot be 8 with another number, because it would always include a 6. So therefore, it would have to be 6 with 2 other numbers adding up to... So either way, this has to be the spaceship. And we know it contains a 1 or a 3. So even if you have 3, 6, and 9, that's only 18, which is not enough to be 20. So this has to then be 1. This is 3, 7. This is 2, 4, and 5 then. This can't be 5 because of the 2, 4, 5 triplet in the box. This has to be 6, 7, 8, and 9. This can't be 7. Oops. Can't be 7. This can't be 5 or 7 because of the 2, 4, 5 triplet and the 3, 7 pair. So this has to be 9, which means this cannot be 9 here. Therefore, this 3 has to be this shrunk. So it cannot be this one then. Right? Because then the spaceships would crash into each other, which they cannot overlap. So this is the box for that. This is the box for that. This is at minimum then 14, which means 15 is the minimum essentially. Right, because you can't have a 1 here in that if that's the case. So the remaining digits here, 2, 4, 5, 6, 8, and 9, though. That's pretty broad. This could be 2, 4, 2, 4. Oh. No, the minimum here is not. This can't be 3. This could be a 3. And it could be 2, 3, 5, and 6. This is, again, this is 5 through 9. This is 5 through 9. The minimum here is 2, 3, 5, and 6 here, which is at least 16. So that's not possible to have 15 or less. And it has to be a multiple of 3 again, because it has to be divided by 3 and then multiplied by a non-3 number, and you can't have, the energy can never be essentially a fraction. So therefore this must be at least 18, which means the 3-digit number must add up to 24. Is that right? 18 divided by 3 is 6 times 4 is 24. So then this does have to be 7, 8, 9. This can't be 8 or 9, so this is 7. This can't be 7 or 9, so this is 8, which makes this 7, 8, and 9. So this is 24. This has to be 18. So this is 11, which means we have 7 left. Or, yes, 7 left. This is 3 and 4. This is 3 or 4. This can't be 3, so this must be 4, which makes this a 3. This has to be a 2. We don't know about this, though. These are the digits 1 through 6. These are the digits 1 through 6, but this can't be 1 or 3 because of the 1, 3 pair in the box. This can't be 3 because of this 3. One of these is a 1. Um, 9 has to be one of these 3 cells. This can't be 2. 9 is one of these 3. This can't be 9 because that would add up to, with 1 to add up to 10. And that would, we have the 1, 3, 1, 3 pair already in the row, which eliminates 1 and 3. Oh, actually, 1 and 3 have to be one of these two cells. Sorry, 2 out of these 3 cells. Because we have a 1, 3, 1, 3 pair in row 7, and we have a 1, 3, 1, 3 pair in row 8. So this can never be 9. Can a 3 ever shrink down to 1? No, because 3 at minimum is a 6. And then 6 times 3 is 18, and one cell can never add up to 18. So the 3 cell has to shrink to a 2, but we're not sure where. So this could either go here as 7, 9 or here as 7, 9. We're not sure which. Or here, well, no, it can't be here as 7, 9. It could be here as 7, 9. Oh, no, they cannot. Okay, so the possibilities for this spaceship are either here or here. Cannot go up, or I guess it could go here. It just doesn't have to overlap, so it could go here. So this spaceship goes either here, here, or here as 7, 9. We're not sure which, though. Um, hmm. This can't be 8. Hmm. Hmm. So the 3 cell cage going to a 2 cell cage means the Lorentz factor is 3 halves. The 2 cell cage can be up to 9. What is that? Does the 3 cell cage, what's the maximum then? Well, the maximum for 2 cells is 17. So it's divided by 2. I think it has to be 16 then, if that's the case. Right? Say it wasn't. The 3 cell going to 2 means energy must be equal to 3 halves of a number. It doesn't have... Okay, it must be a multiple of 3 then. So it cannot be 17, cannot be 16. It has to be 15 then, maximum for the 2 cell cage. Right? Because it's taking a number, dividing by 2, and multiplying by 3. Which means the 3 has to be essentially the multiplicative factor. So it has to be divisible by 3, essentially. So that would be 15. If you have a 15, it could be 15, 12, or 9. Because 6 is too small, because if you divide by 6 by 3, you get 2, and therefore you'd have to have a 3-cell cage, adding up to 4, which is not possible. So it's either 6 with 9, right? So the possibilities are 6 and 9, 8 and 12, and 10 and 15. So this is 10 at most. This is 10 at most. Which means it could be 1, 2, and 7 as the largest digit. So this is up to 7. This can't be 3, so this must be a 6, which makes that a 3. This is up to 7, though. So it's 2, 4, oops. It's 2, 4, 5, 7 as possibilities here. And this, can you have a 10 or less without a 1 or a 3? No, because then it would be 2, 4, 5, right? So this must be a 1 or 3 here. So 6 and 9, 8 and 12, 10 and 15 are the possibilities here. So again, this has to be, well, 1 through 7, but that's already given. Okay, so this can't be 2. 1, 3, 4, 5, 6, 7. But we already have an 8 and 9 in that box, so we already knew that. So that's not helpful. Because these could be very broad. What about this then? Again, you have a ratio of 4 to 3. If you have 4 digits, you have to have at least 12. So you could have 12 with 16. Well, 12 and plus 16 is 28. So that would mean the remaining digits would have to be 8 and 9. But this cannot be 8 or 9. This can't be 8 or 9. So therefore, this cannot be 12 and 16. It could be 15 with 20 and 18 with 24. Is that right? 18 divided by 3 is 6 times 4 is 24. So 18 plus 24 would be 18 plus 24 is 42. Right, which was not possible. So this specifically has to be 15 with 20 here. Therefore, this can never be 2, because 2 cannot add up with 2 other digits to add the 20. So this must be a 2. This can't be 2 anymore. So again, this is what? 15, 20. This is 20. This is 15. So that means this adds up to 10. So this must be a 3 or a 7, which eliminates 3 and 7 from the rest of the row. This has to be 5, 6, 8, or 9. And this adds up to 20 without a 7. So, and with no 2, 3, or 4. Well, it couldn't be with 2. So this has to be 5, 6, and 9, which eliminates 5, 6, and 9 from the rest of the row. Whereas the 8 then, it can only be here. So this is 8, which makes this 1, 2, and 4. This can't be 2, so this becomes a 1, 4, 1, 4 pair in row 5. So this must be a 2, which means these can't be 2. This cannot have 1 or 4 because of the 1, 4 pair. We know this is at maximum 10, and for a minimum, this would be 2, 3, and 5 to add up to 10. So this has to be the maximum. This is 2, 3, and 5, which forces this set to be 7. This has to be 5 then. This can no longer be 3. This can't be 5. None of these could be 5. This can't be 8. Whereas the 8 in box 4, it can only be here. So this is an 8, which means this can't be 8. We have a 5, 6, 9 triplet in box, what is it? Box 4. But the 9 has to be one of those two cells, which means this can't be 9. We now have a 5, 6, 5, 6 pair in column 4, which eliminates 5 and 6 from the rest of the column. That makes this a 7. This can't be 6 or 7 anymore, so this is 9. And this has to be 8 for what's remaining. So this can't be 8 anymore. This has to be an 8. This has to be a 6, because this can't be 6. So therefore, this has to be this can't be 6. This is 4, 5. This is 10. It shrinks to a 2 length cell, which has to add up to 15. Well, this can't be 7 and 7 and 8. So this cannot be this where it is. So it has to be 6 and 9 here or here. So either this is 6 or 9 or this is 6 or 9, and one of these two cells is the shrunken spaceship. So this can't be 6 because we need a 6 with a 9 here, because it can't be 7, 8 anymore because of that 7. So this must be a 4, which means these can't be 4. This has to be a 6, 7 pair. This can't be 6. This has to be 1 or 4. This is a 6, 7. This is a 3, which forces this to be 7. Forces this to be a 3. This can't be 1 because of that 1, so this is a 4, which makes that a 1. This is a 4, 5, 6 triplet, so this can't be 4, 5. The 7 could only be with 2 or 1. So this can't be 7 anymore, and it can't be 4 or 5 because of the 4, 5, 6 triplet in the box. So this must be a 2 then. This can no longer be 2. We have a 4, 5, 4, 5 pair in column 9, which eliminates 4 and 5 from the rest of the column. The remaining digits are 6, 7, and 9 then, with 1 and 3. So this is 6, 7, 9, but this can't be 7 or 3. 8, where can 8 be? Because we have 8, well, 8 could be here, so it could be still 1. Well, 1 can't be any of those, so it could be 8. And 6 and 9 have to be either here or here. So this has to be 2 or 4 to add up to 10. This can no longer go down here as 7 and 9. It cannot go here to 7 and 9. Well, it can't go here as 7 or 9. Where does it go? It has to go here. So this is the shrunken spaceship this way, and it has to be 7 and 9. So this is 7, 9, which means this can't be 7. This has to be 5. We have a 7, 9, 7, 9 pair, which eliminates 7 and 9 from the rest of the column there. Therefore, this is 2, 4, 5, 6, 8. Well, this can't be 8 because of this. Where is the 8 in row? Oh, yeah. I guess this had to be 8, right? Can't be 2 or 4. So this must be 8, which makes this a 2. So this can't be 2. This can't be 2. Where is the 2 in box 7? It has to be here. So this is a 2. And we don't know where this spaceship goes. We don't know what... this has to be 6 and 9. So this is 1. This is 2. Therefore, this is 8. This has to be a 6, 9 pair, which means this can't be 1 or 3. So this has to be... The 1 or 3 has to be here. So this has to be 1 or 3 here. This is the spaceship that's shrunk. What could this... So this one has to go... So this one, we know the spaceship is at least this. It must be a multiple of 3. So it must be either 15, 12, or... what else? 15, 12, or 9. Well, these can't add up to 9. This can't add up to 9. This can't add up to 12. This can't add up to 12 because it's 13 at least. So it has to add up to 15. So therefore, this must add up to 10. The only possibility then is 5 and 3 to add up to 10 because that's the max. This becomes 1. This can't be a 5 anymore, so this must be 4. This 4 means this can't be 4, so this is 5. These can't be 5. This can't be a 5. Remaining digits. This can't be 1, so this can't... It must be a 4, which makes that a 1. This 3 means this has to be a 6, which makes that a 3. This 6 means that's a 7, which makes that a 6. This can't be 6 anymore, so this must be 4, which makes that a 6, which makes that 4. And this is just all Sudoku now. Except for this part, I guess. The remaining digit here is 5. The remaining digit here is 7. So this can't be 7, so this must be 9, which makes that a 7. This 9 means this has to be 6, which makes this a 9. So this can no longer be 9. So it has to be 7 and 8 added together, because 6 and 7 add up to 13, but we need essentially digits adding up to 15. So therefore, it has to be here, and this must be a 7. So this is the last part of the special theory relativity rule. So this must be 6. This 7 means this has to be a 9, which forces this to be a 1 to add up to 10 with this. And now we just do normal Sudoku. So this becomes a 3, this is a 1, this is a 3. This 7 means this has to be 5, which makes that 7. This can't be 6 or 9, so this is 5, which makes that 6, which makes that a 5. This 5 and 6 makes that a 9, which makes that a 6. And that's how you solve it. Pretty cool, actually. Very cool, very thematic. Just a very interesting idea. It definitely limited things. So I'm not really sure why this was considered hard because I felt it was very restrictive in what you could do, right? Because you have one Lorentz factor. It's not like the spaceship is changing in multiple different possibilities. So it can only go in certain directions. Maybe just it's hard just to understand what the rule set is. I hope I explained it actually. I hope I explained it well so that you could understand it too. Anyways, I hope you enjoyed this solve and I'll see you next time on Frank Puzzles. Take care.